testing.
My name is Jacob Arnold, and for this project we had to create two competing algorithms for different requests or questions. For me, I chose the question of finding or computing the nth term in a Fibonacci sequence and writing two algorithms for that. So to complete that, I first created a brute force algorithm, and then also we'll take a look at a matrix or matrix algorithm as well that was used to answer this question. So we'll go ahead and take a look and get started now at the brute force algorithm. This was created within Visual Studio using C++ through FAU's online portal access that I use to complete my schoolwork projects. So you'll see here I've got a couple different libraries. Those are mostly all standard except for the header, the time.h header file there is going to be used as part of the runtime calculation in conjunction with this clock t here, tstart. This void bf search is a function that I'm going to use within my main function here. It's used as part of the calculations if we are trying to extend the Fibonacci sequence or even review to see if it is less than or equal to 2 as well. So it deals with the calculations for sure. So the int main starts here, and again this clock t is used as part of the runtime, and then we have a couple of arrays that are initialized. A few different integers. Ends here are going to be used for the nth term user inputs and calculating that. Runs is going to be used to make sure that we run through the algorithm, the decoding 5 times. You'll see this while loop is what ensures we do that. First, I ask the user to give us what they want to have for the first integer in the Fibonacci sequence, and that gets input here. Then we have the user input the same thing for the second integer, that goes here. And then we ask them for what nth terms they're looking for, and that goes into n. From there, we send all that information over to the bf search function. And so we check first after a couple of initializations of more integers to be used in these loops. We check to see if it's the n is less than or equal to 2. If it is, then we just print out the array and then let them know what the nth term is going to be. And then we go into if it is greater than 2. And then we run, if it is, we go ahead and create some calculations to extend the Fibonacci sequence in the array, and then go ahead and print out that array and then show the nth term to the user, just as requested. So with that, we're going to go ahead and build this solution, and then go ahead and debug it or run that. So first, we'll just go with the usual one. So first term being 2, and that, and let's say we're looking for the 5th. So there we go. That prints out everything for us. We'll do a little bit of a bigger one here, 5 and 10, and we're going to go for the 7th term. Gives us 105. We'll go back to 1 and 2, but this time we're just looking for the second term. Gives us 2. We'll go to 3 and 6. Oops, not 63. And then let's go for the 10th term again here. Okay, 267. And then we're going to go 4 and 5, and we're going to look for the 9th term. And you'll see the total runtime, 3776. So a little over 35 seconds there. Divide that by 5, it'll be a little over 7 seconds for each one of the passes through. And that, of course, includes user input that we have to do here. So, and this is the printf statement where that timing is coming from, all using the time.h and clock t. So now let's go ahead and open up the matrix algorithm, so the competing algorithm we're going to have with that brute force. So for this one, you'll see I had to add quite a few different of these libraries. The solution that I was working with came with a different header file that had included a lot of these different libraries, but it does not come standard with Visual Studio. So I had to manually input some of these libraries to make sure that this code works for me. Everything else pretty simple, but then you get into some of the function calls. So, well, functions, not the calls. These are just some of the functions that we're going to be using throughout this coding to make the calculations with the matrix. So we'll go into main and clock t. This is going to be used in the exact same fashion as the brute force. So we can kind of get a look at runtime for the entire project here. And then you have a couple of integers. N is going to be used for the user input of what nth term they want to look for. And then runs is going to be used, again, in the same fashion to make sure we go through the coding 5 times, get 5 answers. So the first thing we're going to do is look for that nth term from the user input and then put that into N. From there, we're going to send that to fib through N, or I'm sorry, using the nth term that they were looking for. And we come into here, and so it's going to be used, and you'll see it's taking a look to see if N is equal to 0. If it does, returns to 0, returns 0. Otherwise, we are going through to the next function here of power. So that's going to go into power here, and it's going to start working with the matrices, and we're, again, sending over N and that other matrix and running through this for loop to go through to multiply in case if we need to add on to that Fibonacci sequence and find those next characters. So within multiply, that's where these calculations happen here to go ahead and continue to extend out that Fibonacci sequence if necessary. And then everything gets returned back through the initial statements through in here and then to get char. So we will then do the runs to make sure that we increase runs each time to get through to our 5, and then a printf statement for our runtime. So let's go ahead and build out that matrix, and we're going to start that. So what's the term that we're looking for? We'll start simple. We're going to look for 2, okay? And we're going to go out to 6, and then let's do 10. Let's do 9. Keeping in mind that this is using the standard Fibonacci sequence, so the first 2 integers being 1 and 2. That's how this is calculating. And then let's do a 7. And you'll see total runtime of 24, so a little under 5 seconds here. So it takes less time, but that's to be expected with there being less user input throughout the coding and the solution that I came up with on these. So that is my project. Thank you very much.